Okay, so here we are. This is part 2 of exam 3, and we're asked to solve and plot the temperature profiles. And it says that for a hint, we should start with empty vectors, with the right side of the Crank-Nicholson equations. Let's see, where NT is equal to 50 here. And then fill proper values of B, paying special attention to the insulated end. And looks like this is our example graph, what it should look like. So in part 1 we solved for our nodes, and also for indexing I demonstrated this guy here. So let's go ahead and pop on over to Google Colaboratory and let's get this done. Okay, so first thing we need to do is we need to import our libraries. So import numpy as np, and then from plotly.subplots import make subplots, and then we need to import plotly.graph objects, and I'm just going to say that this is going to be Go, just graph objects, and that'll help us make the plot. And then we're going to go ahead and import plotly.io as PIO, and then from scipy.linear algebra import solve banded, and then also we're going to go ahead and mimic the dark background of the plot. So pio.templates.default, we're going to set that equal to plotly dark. Let's go ahead and run that. Alright, we're looking good, no typos so far. Now what we can go ahead and do first is specify the length of the bar. So we can say nx equals 50, so it's 50 meters. And we also need to specify the time period. And it said, let's see, what did the problem statement say here? What were we asked to do? It says plot the temperature profile of the bar every 5 minutes for 1 hour. Thermal diffusivities in seconds, SI units in seconds. So we're going to go with seconds here. So what we can do is we're gonna do NT is equal to 3600 seconds. So that's 1 hour. And that's the total time period for the temperature profile. And let's go ahead and make an empty array for the temperature values, and we're going to make that a float. That way it doesn't scream at us later on. And basically we're just making temperature values, and we're filling the array all with 20 because that's the initial temperature for both sides. And this is basically saying that we want the whole array, we want 50 elements in that array. So we're just putting it, that's our temperature profile. And also we know that the temperature on the left side, so T0, the very first element in that temperature array, is going to be 50 degrees Celsius because it spiked. So those are our initial conditions, that's our constraints that we've got. Also, we're given that alpha is equal to 1. We're given that the alpha is 1 meter squared per second. And we're going to make that a float as well so it doesn't yell at us. Nah, not bit length. We also need to define delta x, and that's going to be equal to 1, also a float. I don't know why it keeps doing bit length. We don't want that. And then we need to do delta t here, our time intervals. That's 1 second. And now we can go ahead and create an array with evenly spaced values with the interval nx, so we can get our step values for that. So np dot a range nx times delta x. And also in the previous part, we defined r. In this case, we're going to keep that. So r is equal to alpha delta t over 2 delta x squared. So I'm just going to go ahead and scroll down a bit. What we've got is r is equal to alpha times delta t over 2 delta x squared. And we can create a blank array now to fill coefficient values with for the left side of the equation. So np dot zeros and 3, because we have 3 coefficients, and nx minus 1 because we've got 49 temperature profiles here. It's listed as 50. We technically have 50 given that we have a step size of 1 meter, but the very right temperature does not change. It's perfectly insulated, so we have 49 temperature steps. So then what we can do is designate the coefficient for Tj minus 1, and this is going to be a 0. So basically what we did in this step here, this 3, it basically makes an array that has arrays within it. So it would kind of look something like this. This first one, the first array being all the first coefficient, then this would be the second coefficient and the third coefficient. So Tj minus 1 and then Tj and then Tj plus 1. So first we're going to define what Tj minus 1 is, and that's the first array, so 0, comma, and then 1 until the end. So it's the first element, and that's negative r. And we also have this guy here. There's a comma there, and that's because it's the first array. Oh, dummy me forgets an equal sign. Okay, and this one is 1 minus 2 times r, and that's for Tj. And this guy we're going to designate Tj plus 1 now. So 2, comma, colon, negative 1, so the back value. That's the last value. And that is going to be equal to negative r as well. And now we have that special case for node 49 because the temperature doesn't change. So we also have to designate where that is in this array. And it's going to be right there, the last value. It's definitely going to be the last value because it's on the very right of the bar, the very right side of the bar. It doesn't change. So, and we also figured out that it was 1 plus r in that equation. After we applied the fact that Tj plus 1 is equal to Tj, that's where we came up with that coefficient. And now what we need to do is define our b vector. So we're just going to create a blank array now. So np.zeros, and we're going to specify 49. So nx minus 1. That's going to be our size. And now what we're going to do is create the plot. So figure equals make subplots, and then rows equal 1, column equal 1. That's calls, not call. Okay. And in the problem statement, it's going from colder to hotter as the time goes up. So what we're going to do is we're going to create a color map to match that with hex code. So what we're going to do is we're just going to basically make a list here. So we're just going to name a color map, and that's open parentheses, and I'm just going to go ahead and put that down. And this first guy, this is going to be number 38OBEE. And that's going to give us that blue color. And basically we're going to go from blue to red. And I've got I color picked these, so that's where I'm getting these from. I'm using a color picker on that image. So this is going to be 40CD2A, and the next one's going to be 9AE 62D. This is going to take a hot sec. And then this one's going to be E2E 531. This one's going to be EC BF1C. And what I'm doing is I'm going down by color and by minute. So this is incremented by every 5 minutes, since that's what it asked for. So basically we're going to have 12 values, 13 if you include the initial. This one's going to be E1 8625. This is E86 924. This is, I forgot my quotes there. This could be E44 E13. And this is going to be CF 3719. And then we've got BA 2714. And then we've got 2 more to put in. Second to last one. This is at 55 minutes. This is A71 C0F. And then our last one at 60 minutes, our last color, is going to be B91610. And then we can go ahead and close that parentheses. We've got one down here. I'm just going to delete that. It's kind of far. I'm going to leave a space just so that way it looks pretty. Okay, so now what we can do is we can plot the initial temperature profile at time equals to 0. So we're going to do figure dot add trace, and then go. That's our graph objects. So dot scatter. So we can make a scatter plot. And then x equals to x, y is equal to t, so our temperature. And our name is going to be equal to f. And then we're going to do 0, colon, and then we're doing this for spacing reasons. Basically I'm just taking four digits and spacing out the words that I'm going to make in the name. So basically it's just going to be, I'm labeling it 0 minutes, so time equal to 0. And then after that, we're defining that it's a line. So, and I'm going to create dictionary here. That way we can map the color. And I'm just going to do color equals to color map. And then I'm going to use the correct indices. So it's 0, the first element here. Okay, so that should plot our temperature profile at t equals to 0. Let's go ahead and run that and see what that, yep, that looks right. Let's see, yep, stops at 49. That's about what we want. So now that we've got our initial time, our initial temperature at t equal to 0 plotted, we can go ahead and plot the rest of them. So we're going to do for I in range 1 comma nt plus 1, and we're doing nt plus 1, so that's time plus 1, so basically 3,601 seconds, because we want to plot the full 60 seconds, or not 60 seconds, but 60 minutes. So once it surpasses an hour, then we stop. Can't forget that little colon there. Python will yell at me. And then for indexing reasons, we're including everything here except the first value, because we know the first value, so we don't need to calculate that. This is going to be equal to R times our temperature profile down to the second element from the right, so the second to last element, and that's just going to be our TJ minus 1 there. And then we can go ahead and put in 1 minus 2 times R. And then we're going to put in TJ, so that's everything except the first and last. And then we can do our next one, which is TJ plus 1. So T, and that's the third element. So at place 2, indexing starts at 0. This is the third element in the array. So that should give us our B vector there. For each time period, that should calculate it and populate it. Now we're going to do B0 is equal to B0, so the previous, plus the new one, because it's all based on the previous values. And then we're going to do the same thing here. B minus 1 is equal to R times T negative 2. And that's our TJ minus 1 there as well, from the right side. And then plus 1 minus r, because this compensates for the 49th node, and that's what we're calculating right now, is the 49th node, since this is the 49th node is different. Then we're going to do t minus 1. I'm fat fingering. Okay. Now we can go ahead and type out what our temperatures would be in the for loop. And we're going to use solve banded. And now it's asking for how many diagonals there were. And going back to this piece over here, I stated before that in our array, we should have our tj minus 1 here to the left, our tj, and our tj plus 1. And because we don't have a tj plus 1 from the 49th node, we only have the middle and the bottom. So what we can do is, this is going to be 1, 1, and then A, and then B. So that's going to use that's going to calculate that. And then now what we need to do for every time we're going through the for loop, our index, we need to do for I %300. And what this is going to do is basically 3600 divided by 300 is 12, and that's going to give us 12 plots. And since we're plotting every 5 minutes, 60 divided by 5 is 12, so we're going to need 12 plots. And it'd be a lot easier if we could work in minutes, but SI units says that we got to work in seconds, so we got to use 300. And now we're going to do fig.add trace, go.scatter, x equal to x, comma, y equal to temperature, comma, name. And then we're basically going to do the same thing. Well, I shouldn't say the same thing, but similar to what we did to plot the initial temperature before the for loop. But this time we actually have to calculate, we have to transfer everything from seconds to minutes, because that's for consistency reasons. Since the example on the problem statement was like that, that's what we're going to do. So we're going to do I divided by 60. And then we're going to do that to 4 figures as well. And then we're going to go ahead and close that off. And then we're going to put minutes at the end, just like the top. And then we're going to go ahead and specify line. And then we're going to put our color in there, so we're going to make a dictionary. So color is equal to color map. And then the these indices are in, they're string values, they're not integers. So what we need to do is make it an integer. So we need to do int and then I divided by 300 so that we get it in minutes. Then we go ahead and close that off. And we should be good to go for that one. And then we get out of both of these, for the for loop and the if loop, and we can do figure.show, and that should plot it for us. Let's see what we get. Invalid syntax. Okay, what are we doing? It looks like just a small little typo. Okay, let's see what that does for us. Another error here. What are we getting? Invalid property. Figure.trace. Line. Okay, that's not looking right there. Let's see what we did. What did I do here? Let's see, it looks like it only plotted, or it's plotting them at the same time. I'm not seeing my mistake here. Okay, what happens if we comment out one of these? Let's see what it goes to. What are we looking at? Now it's still going back and forth. Did I forget a float anywhere? Ah, this should not be a minus. I'm pretty sure that should be a plus. Now let's, actually that should be, these need to be uncommented. Okay, let's see what we got now. There we go, okay. Yep. So if we compare that to this guy here, we are looking in good shape. So that's it for part 2.